In this video, I'll show you how to easily cut through the messy, pitfall-prone process of doing SDK version checks on Android with a simple two-step procedure. We'll go over why the traditional way is failing you and why this way is so much easier to understand. This video is broken down into 3 parts. Well, first we'll take a look at a basic implementation, and we'll take a look at some of the pitfalls that arise with it that you may not expect. Then we'll move on to the two-step process. Well, first we'll introduce a DI framework, and then we'll clarify the meaning of some of our code with a few additional constructs. Now, if you're using Java, you can benefit from some of these things, but this is primarily geared to anyone who's using Kotlin in the project. If you'd like to follow along, there is a link down in the description to a GitHub repository, and that repository has 2 tags in it. The first tag is a start tag, which shows you the initial state of the project, and there's a finish tag, which shows you the final state. Now, if you'd like to follow along, feel free to pull it down. Otherwise, we're going to go ahead and jump into the app. Here I have an emulator running the application, and it's incredibly simple. All it does is it has a button that says Show Notification, and whenever I press it, I get a notification that appears in my drawer. For those of you who have worked with notifications on Android before, you're probably familiar with how many times Google has revised that API. Even for this simple application I just showed you, there's at least 3 things that we need to do to accommodate different versions of the API. Let's take a look at that inside the code. Jumping into the code, you can see inside of my build.gradle file that I have a minimum SDK of 21 and a target SDK of 33. So that means I'm supporting 12 different versions of Android, and there's quite a few API changes that have occurred between those 12 versions. For example, if I jump over to the main activity, inside of my onCreate, the very first thing I have to do is request permission to show push notifications, but that's only on Android 13 and above. So that's one question. Let me jump to the view model, which is the view model controlling everything on that one screen with the button on it. And there's 3 other questions that I ask here. So for example, whenever I create the push notification, I have to add a pending intent to it, which is basically the action that runs whenever you tap it in your system tray. Android Marshmallow and above allows you to have mutability properties on it, while anything below that, like Lollipop, does not. If I scroll down a bit further, you can see Android Oreo and above allows you to add push notifications to particular channels, while everything below that does not. That's the second thing on the screen. And if I scroll down a bit more, I also have to check one more time if they have permission to show push notifications. So that's again API 33 and above, and I have an entire if check to do that. So now that we know all of the questions that our application is asking, let's take a look at the problems. Now I see 3 major problems with this approach. If we go back to the view model, you can see here, this if statement has a lot of code inside of it, but it's not really clear as to why it's asking that. I have to infer the context by looking inside the body, and I realize, oh, this is determining whether or not I can show a push notification inside of a channel, but the if statement doesn't give me any clarity on that. If I scroll down here, you can see I'm asking whether or not you're on API 33 and above, and then I'm doing the same thing here. So not only are these if statements unclear, but they're also duplicated in a couple cases. And plus, I can't unit test these things. Particularly here where I have both a positive and a negative case, it's really difficult to do that. I can do some fancy footwork with reflection, but thankfully we have tools like DI, which is intended to help us with this. So that takes us out of step 1, where we looked at the problems. Now let's go to the solution, starting in step 2. The first part of this solution comes by way of using dependency injection. Now, my personal preference is Dagger Hilt, and if you're following along with the sample code, the project is already set up for it. But let's say you use Dagger 2 or some other dependency resolver, you could also get very similar benefits. If you want to know how to set up Dagger 2, you can take a look at this link in the description where it takes you straight out to their documentation. But since the project is ready to go, let's go ahead and start adding in what we need. I'm going to create a new class that's going to serve as my module. So I'm going to call this build version module, and I'll put that underneath of a DI package. So what's my point in doing this? Well, if I go back to my view model, you can see every single if statement is comparing against the exact same value, the SDK INT. And that's something that can be injected with Dagger. So I'm going to go back to this module, and let's go ahead and add that to the object graph. First, I'm going to follow their convention by creating this as a module, and I'll import it. Next, I'll go ahead and provide that value that we're comparing all throughout our code, just like that. I'm going to give this a unique name. The way I typically like to do that is I'll create a companion object inside of my module, and I'll create a const val with the same name of what I'm resolving. So in this case, I'll say SDK INT, and I'll use the fully qualified package name of the module and the property as its value. And then I can add @named right before this and pass in the value SDK INT. So if at some point I happen to have another int somewhere in my object graph, I can now distinguish between them because this one has a name and the other one at some point should as well. the last thing I'll do is tell Dagger where to install this module. So I'll use the app install in annotation, and I'll put this inside of the singleton component, just like this. Now this is fine because this value is super lightweight and it's never going to change. Let's start using this value throughout the rest of our app. Jumping back over to our view model, let's go ahead and inject this inside of our constructor. I'll make this a private val and call it SDK INT. And of course, since this is a named parameter, I'll put @named before it and bring in the entire name. Now I'll go ahead and replace every instance of that constant with this variable that I'm injecting, just like this. I'll do that here as well, and then one last time at the bottom. Now my personal preference is, since this is an entire block of code that's just inside of an if statement, I'm going to go ahead and back this out and do an early return instead. And then of course I'll flip the Boolean logic just like this. Now you can see I have a couple problems inside of my code. Now the linter isn't aware that I'm actually doing the due diligence in order to do these checks. So what I'm going to do is I'll select the offending code and then press Alt-Enter or Option-Enter on my keyboard and then suppress it just for this function. I'll go ahead and copy this suppression to my other offending places, and now everything has been fixed. Now notice I'm not putting this at the class level. I want to keep this as localized as possible. Since I really am doing the due diligence, it's just that the IDE doesn't know it. So that takes care of everything for this class. Let's jump over to the main activity and do it there as well. Now in most cases, whenever you look at how Dagger works, you can simply inject a variable using the inject annotation like this on a late init var. And if I call this SDK int and set it equal to int, in most cases that's all you need to do. But we'll need to make a couple changes. First of all, you can see if I hover over this error, you can see Kotlin is telling me that it doesn't support late init vars with primitive types, so things like ints, strings, and so forth. So I'll get rid of this and simply set it equal to 0. Now, of course, we also have this as a named parameter, so I'll also have to make sure that this is named. This actually still won't work because whenever this is compiled down into the Java code, this is going to be converted into a private variable, which means Dagger can't inject anything inside of it. So to fix that, I'm just going to expose this as a JVM field. Now, notice we did do a little of extra work here. That's because we have a very specific scenario. We're dealing with primitive types that are named. So that's why we have the named parameter, and that's why we have the JVM field, because we couldn't use a late init var. So now let's go back and let's replace this constant with the variable we injected, and then suppress the linter. Everything's looking good on this side. Let's go ahead and build the application and make sure that it functions just as it did before. My application is built, and if I press the show notification button, you can see I'm getting everything just as I did before. So functionally, there has been no changes, so that completes this step. Now let's move on to the final step where we're going to clarify the meaning of our code. Now the only advantage that we have right now versus when our project started is now that we can unit test these things, but it hasn't really made the questions that we're asking any clearer. Let's go ahead and take care of that now by creating some extension functions on top of an int. Now, if you have a Java-based project, you can't use extension functions like you can in Kotlin, but you could do something very similar with a static function on a static class and get basically the same end result. Let's go ahead and do this with extension functions though, since we're in Kotlin. The way that I like to do that is I'll create a dedicated package. In this case, I'm going to call it ext for extension functions, and I'll place it under the root of my project. Inside of there, I'll create another Kotlin file. I'll call it int.ext.kt. And I'll make sure that this is a file so it doesn't create a package structure out of this. And for now, it's empty. The way that you can create extension functions inside of Kotlin is just like this. Fun, and then the type that I'm extending, which in this case is going to be an int, and then I'm going to create a function on it. Let's go back to our main activity, and we'll start here. Now, what is the question I'm trying to answer? In this case, I'm trying to see whether or not the device requires me to request push notification permissions. So to clarify this inside of a function, I'll copy the code, and then for my extension function, I'll call it something like requires notification permissions. And then I'll set it equal to the values that I just copied. But in this case, I'm going to replace SDK int with this, referring to the actual integer itself. Then I can go back to my main activity, I'll delete this comparison and just keep SDK int around. And then I can say dot requires notification permissions, just like this. Now that is a whole lot clearer. I don't need to look at the context of the code to understand what question I'm answering. Let's do the same thing inside of the view model. If you remember, I'm answering the same question twice. I'll scroll down to the bottom, and I'll replace it there as well. Requires notification permissions. Now if I scroll up, I have a different question that I'm asking. Now this comparison is answering whether or not the device supports push notification channels. So to clarify that, I'll copy this version code out and I'll create a new function. And just like before, I'll have the exact same logic. Now, of course, if I wanted to answer the inverse question, I could just invert this Boolean, but I'll just keep it this way for the sake of consistency. Going back to my view model, I'll use my new function. Supports notification channels, but in this case, I'm doing the inverse because I have an early return. So this would be if it does not support notification channels. Obviously, you have some flexibility around how you design this. Now let's scroll up and answer the final question. This is answering whether or not it supports mutable pending intents. So one more time, I'll copy out this version code, go back to my function, and create a new one. And with my last function in place, I'll replace the logic just like before. And that's it. Let's go ahead and build this application and make sure that everything works just as before. With the final version of our application built, I'll press the button one more time and see that it behaves just as it did before. So that's the entire process. We used HILT to inject the SDK INT throughout our application, then we wrote an extension function to clarify what each comparison meant, and then we just replaced all of the comparisons before. In this video, we used Dagger HILT for dependency injection, which is Google's new recommended tool for this purpose on Android. But if you're on an older project that uses Dagger 2, then continue on to this video here, where I show you how to upgrade an entire Dagger 2 project to Dagger HILT in less than 15 minutes. Otherwise, I'll see you next time on TLDR Android. Thanks and happy coding.